QuadQuiz!
Brought to you by Math with Sir Lester. There are 3 questions for this video, and you are to answer them in 15 seconds each. Are you ready? In 3, 2, 1. For this given function here, first question. What is the vertex of the graph of the given function? The vertex is at 0 and -4. Next question. What is the axis or the line of symmetry of the given function? The graph of the function is symmetric at x equals 0. And the last question, how many x-intercepts are there in the graph of the given function, and what are these? We have 2 intercepts. It's at -2, 0 and 2, 0. Did you get 3/3? If not, please continue viewing this video. The vertex of a quadratic function could also tell us the axis or line of symmetry. That is why it's very important for us to properly get the correct vertex. The vertex is a point in the graph of our quadratic function where our graph changes its direction. It's also known as the point of inflection. The third concern of this video, which is actually on intercepts, there's another method to that, but we could easily solve for how many intercepts are there and what are the intercepts. Let's just start with the vertex and its connection to the axis or line of symmetry. To solve for our vertex, let us try to use the correct coefficients of this quadratic function. The coefficients of quadratic function is similar to the coefficients of quadratic equation. We have A coefficient, we have B coefficient, and we also have C coefficients. And the A coefficient is again the numerical coefficient of x squared. In this case, we have 1 because that's 1x squared. Our B coefficient is the coefficient of x, and since there's no x term here, that's 0. And the C here is our constant. It's not just 4, but more importantly, it's -4. These coefficients can be used to solve for the vertex. Our vertex is a point in the graph, hence it's a combination of an x and y coordinates. For our x coordinate, it's -b/2a. So we simply plug in the a and b coefficients here, and for our y coordinate, it's 4ac minus b squared over 4a. Same thing, substitute your a, b, and c coefficients. But you don't need to worry much about this. You don't need to memorize this formula, because here's the catch. Just like any other points in our Cartesian plane, once we could guess our x coordinate, simply plug in this value on our given function, and automatically you will have your corresponding y coordinate. So no need to memorize this, simply familiarize with the first coordinate. So with this, let's try to substitute the a and b coefficients here. Since our b is 0, so -0 over 2 times 1. Now we know the result of our denominator, but since our numerator is 0, automatically our x is 0. This will be substituted on our given function. So our given function is f of x be equal to x squared minus 4. We will substitute f of 0 here, or we will use f of 0 because the x coordinate of our vertex is 0. So 0 squared minus 4. We will get a result here which is -4. This is why our vertex earlier in our answer is at point 0 and negative 4. This is the point in a graph where the graph changes its direction. This vertex could tell us a lot. As mentioned in our previous videos, this could tell us about the maximum or the minimum values of our function. This could also be a hint on the domain and range. But here, since the second concern of this video is the axis or line symmetry, this could also be used here. Now, the axis of line symmetry, now let me just try. Say for example, this one here. So we have 0 and negative 4. 1, 2, 3, 4. Of course, this is our x-axis. That's our y-axis or our f of x. By the way, these are equal. Y is equal to f of x. So we have here your 0 and negative 4. These are vertex. Okay? Looking at our a coefficient, if you would like to review on that, since our a coefficient is positive, our parabolic graph, just like this, is opening upward, or its concavity opens upward. The axis of symmetry, or the line of symmetry, is an imaginary line that can be drawn on our graph, which will divide our parabolic graph in exactly mirror images. Okay, that's the axis of line of symmetry. The axis of line of symmetry is actually this line here. This y-axis is the line of symmetry, as this divides our parabolic graph into two equal parts or mirror images. We have here and there. If my graph is accurate, these two should be in mirror images. And we are talking about the equation of this line. In our previous discussions in Math 8, if it's a vertical line, we are given with x is equal to something. And that something is the point where it touches the x-axis. Our axis or our line of symmetry pertaining to its connection to our vertex is simply this one here. Once you could get your vertex, the x-coordinate of your vertex is automatically your axis or line of symmetry. This was our x earlier. This is also our x, our axis, or rather axis or line of symmetry. Since our x-coordinate of the vertex is 0, our axis or line of symmetry again is x equals 0. That is why the vertex is also connected to the topic of or concept for the axis of line of symmetry. You don't need to draw. I'm just trying to illustrate it here, but you don't need to draw. Automatically, once you are sure of your vertex, take the x-coordinate, make it an equation. That's your axis or line of symmetry. The third concern of this video is different from its connection to the vertex, but all about intercepts. More specifically, x-intercepts. The x-intercepts, in general sense, are points on the x-axis where our graph intersects it. Okay? Looking at our graph here, we have a specific point in this area and a specific point in this area. Okay, looking at our graph, automatically we could say that there are two of them because there are 2 points in our graph that passes through the x-axis. Of course, again, my graph is not accurate, so we cannot tell the exact value of this one here. But just by the graph itself, we know automatically there are 2 intercepts. In this video, you are not tasked to draw the graph. So how would we know that there are really 2 intercepts without even graphing? The x-intercepts are actually, or the number of x-intercepts are actually equal to the number of roots. Okay? The number of roots of your equivalent quadratic equations from your quadratic function, that automatically answered how many intercepts are there. Okay, without even graphing, let's look at the equivalent equation of the function. So simply equate our quadratic form into 0. This is x squared minus 4. That's equivalent to our given function. Equate into 0. Of course, in our topic before, you might want to review on this. We also have strategies in solving for the roots. In this case, since there's no b coefficient, we can use here extracting square roots, where we move the constant on the other side. We have it here, okay, or add 4 both sides. And when we take the square root of both sides, don't forget that when you take the square root of a constant, you will have positive, negative. You have x is equal to positive and negative 2. Hence, your roots are x equals positive 2 and x equals negative 2. This satisfies the situation that we have two intercepts because we have two intersections here. And with this, we can say that this is actually negative 2 and this is actually at 2 because we have here the answer x is equal to 2 and x is equal to negative 2. Again, intercepts, the number of intercepts are related to the number of your roots. But our intercepts are not just values of x, but more importantly, as mentioned, they are points on the graph. So we need to structure them as points. The intercepts are the point on our graph where the value of your y-coordinate is 0. So simply include here the value of your x. 2, 0, and negative 2 is 0. You can interchange them because they are just points on the graph. Doesn't matter which comes first. So the intercepts of this function, we have two of them, are 2, 0, and negative 2, 0. Again, x-intercepts are related to your number of roots, and once you will get your roots, simply pair them with 0 as y-coordinates and you will have your result. These are all the discussions to the answers for this QuadQuiz. Subscribe now.